Hello everyone, I am Tasfahun Alamu. I am a senior breeder at Ethiopian Institute for Agricultural Research. In this video, I will try to show you how to use R for data management and inspection. So in this video, we'll follow the following topics, outlines. One is the set working directory and create project. Second part will be import the data from the Excel, text, and CSV formats. Third one will be data cleaning and inspection. That will include graphical data inspection using different graphs like scatter plot, box plot, SC, and also statistical data inspection. That includes summary and other tests. And finally, we'll use detecting outliers. So after saying that, we will go directly to the R Studio and we'll see how practically we will do these topics. So when you go to the R Studio, we'll start with setting working directory. So to set working directory, first to know what is the importance of setting the working directory. So setting the working directory is important because one, it is help us to easily access the file inside the working directory. In addition, it will help us to know exactly where we save our output file from the R. So because by default, when you save outputs from R, it directly will save on the working directory, so that we will find these files easily. So to set the working directory, we will use two methods. The first one will be using the menu driven one. So we will go to the session, then we'll go to the setting work directory button, and then we'll choose from the drop down menu, choose directory. So we will select the directory what we have been interested to use as working directory. Here in my case, I use the data management directory will be my interest to make it as working directory. So I will open. So then in this case already will make for me set as a working directory. The other part can be we can do set our working directory using the set working uh, set working directory command. So in this case, to set working directory command, we should give the path of the directory what I've been interested. So in that case, we'll go to the window explorer, and then we'll select the folder of our interest. For example, in this case, I am interested to the folder that's called data management. So in this folder, I will copy the path of the folder. I will copy. So, and then I will paste under quotation in this as a path. So in this case, in R, either we should use the forward slash like this, or we can use double backslash. So in this case, you can easily add double backslash from each of this one, like this, like this. Yeah. So then we run. So we set now the working directory. The other part is creating projects. Create project, where especially it is interesting when you want to create project. If you have some activities that can be done frequently, set the project, create the project will be an interesting part. It means when we directly click the project, we can have an access with the default directory and all information available in that directory. So it's possible to use also create a project. So to create the project, we will have we'll use one. Here we can have this one, this icon that shows create a project, or you can go on file menu, and then we click on new project, and then we'll select the new project, then we can save the selected files here, and then it will give us an opportunity to select the directory. The first one will give us if we are interested to create our own directory, or if the second one will show you if we are using the existing working directory. So in my case, I will use the existing working directory. So we will click it, and then we'll browse the directory of our interest. In our case, here is the data management directory. So we'll select, and then we'll open. If not in your case, for example, you can move here, and then can select, and select. You can go like this. You can access the directory of your interest. Then you'll go, and then you'll open. Then after that, if you are interested to open in the new session, you can click here. If not, you can untick this one. So then with this, you can click the create project button. So it will create for us the working directory. So we now create the new directory. So this is what we have been as a current directory. So when you create exactly, if we create the project correctly, we'll see here data management will be available. Here's the name of the project. So inside this project means all the files available inside that folder will be available here in file. Here we have only one file, CSV file. So this is what we can do for creating a project. The other part is we'll see is how to import the data from text. So to import the data from the text, still we can use two methods. The first method will be menu driven one. Can go here import dataset here, or can go on the file menu and import dataset. Then you will select this text. So from the text directly it brings you to your say working directory. So in this case our data is example one. So I will open it. It is CSV format. So here is a CSV format, but here it's changed to the data frame. So in this case, if your data has a header, you will say heading yes. If not, you'll change. If in the case of separator, if your data is separated by semicolon or tab or white space, you can select one of it. But in our case, the data is separated by comma. We use comma delimited. So we select the comma. The decimal period is the number, especially when you say 69.6. So if you use period or point, we use period. If not, we can select comma or other. Another one may be interesting here is this one. Can click it because it can change the name or the character written by using the string. It will directly change it to factor. For example, here the location is written by character, so you will change it directly to factor. The numerical ones will be continue as integer or as numeric. In this case also we have an option to change the name what we have been interested in. This case, for example, we have example one, but we can say exam one as if we're interested. So then when you import it, our file will be exam one. So here, as you see, we bring the name exam one with data, but that data will have 135 observation and 9 variables. Okay, so the other one is we can use read table or read CSV command. So when you use read table or read CSV command, what you're gonna do is write the command read CSV and then press tab, and then we'll select the file. This is we'll give him the name of the file of our interest to bring it. In this case, we'll give the path or the path of the file, including the file name. And if it is the file is in your working directory, only you can make quotation, and then when the cursor is in the middle, you can touch the tab, so it will list you the file names inside your working directory. So in our case, the working directory, within our working directory, we have the file called example1 CSV, what is our interest. So we'll select this one, and then we'll again tab header. By default, read CSV will show header is true, but in case you don't have header, you can use header is false. But here we have the header, we can select false, true, and then the other separator will be how the data is separated. So in our case will be comma separated, so like this. So that, but after you do that, you should give the name to save the R object. So in this case, for example, exam, then you can run it. So now our data is saved as exam. The other is you can use also a read table command. The same thing that work done like that of the CSV, but read table also help us to import data or text data from our working directory. So in this case also the same thing, we can take the tab and select the file. In this case you can read the tab, then header is true and separated like by comma, then like that. So we can give also the name, the same name, and then you can read the data. In this case, the most important thing is when you use read table, the naming convention should be satisfied, because if you name the any genotype name by using 2 words or 3 words, so it will make a confusion. So it is better to read, when with read table, it is better the name is written in standardized naming pattern. So then you can run it. So now the data is we have read from CSV or from text file. In the same manner, you can use read table to read the text files in any other file types. The other part is import the data from Excel. From the data, to read the data from Excel format, we can use read Excel package. So in order to use that read Excel package, we need to load the package, and then we'll run it. After load the package, we'll use the read Excel command. So that to use the read Excel command, we need first to give the path of the file, and then from that file we also should give the sheet name of the file, the Excel file you want to import. So in this case, in order to get the path of the file, first we'll go to the data we are interested. Here, for example, here we need this data. So first we'll copy the path, the path. Here is the path. It should be under quotation, but as I already told you, we should change the backslash, or we should double it, or we should make it forward slash. Otherwise, the path will not be recognized. Then we should select the data. So the data is example data XLX. So this one will write also the sheet name. The sheet name here is, we'll have RCBD. So it means from the example data file, please bring the data, the sheet RCBD. So it will bring, and we can give the name here, for example, X1. Yeah. So like that we can read it. Or the other is as a menu driven, also you can read by using the menu driven command like that of here. You can import dataset here, or you can also the same thing, you can import dataset and then from Excel. So in this case we will browse the file. So we'll go to the file of our interest here, for example experimental data, then example data, then we'll open it, and then from this, as you see it, we only see the first sheet of the data here. But if you are interested to change the different sheets, if you are interested to import different sheets, you can select the sheets here. Here, for example, our interest is RCBD, so we select RCBD. And if you are interested to change the name of the file, we can say exam. And then here, if our first the first row is used as a row name or a column name, you can click it. If you are interested to see the data when it is opened, you can use open data viewer. So then you can import. That's all. So like that, we can import the data from Excel in this manner. When with this script, like read Excel or read CSV here, it may be interesting, especially if we give the path of the file. It is interesting sometimes because it is easy to reutilize it again and again without going here and there. Okay, so now we already import our data, and then we need to make our exploratory data analysis, and so I will show you how we do that. Okay, already the data we have read our data. So in this case, for example, read CSV, we can example one CSV, and then can read that data. The first thing we should do is we should identify our factor variables. And to do that, first we can check our structure of the data from this line 17. So when we see here the structure of the data, as you see it, our location is character, year integer, treatment integer, plot integer, rep integer. So we have 1, 2, 3, 4, 5 factor variables. So this factor variable should be changed into factor. So this change can be done using in two ways. The first one is using the base factor function. That means, for example, if you dot and then location, then you say factor, then the same dot location. It will do for us. It takes the column name location and it's changed to factor. After that, you save on the same column. So like that, we'll do for all factor variables, like that here in our case, for example, TRT factor that TRT, and also the same thing that rep factor that rep. Yeah, when you check it, you'll see how all the location, and then when you see it, the location, the treatment, the factors were changed already. But the other more interesting, more flexible, and more easy method is using the function on the library method. In the library method, we have a function called as a factor that will easily change our data to factor variables to factors. So that can be done like this, for example, as underscore factor. When we tab, the data, we'll give the data will be dot, and then we'll list the factor, the name of the factor variable to be changed to factor. Location here, treatment here, replication. Yeah. So we'll give the name of the data dot, and then you can run. So here directly it will change with a single line command line. It will change our factor variable into factor. Then after that we will go to our data inspection procedure. So another interesting thing is to use the library data table. This library data table have some fun, interesting functions that easy way to manipulate our data and to produce some summary statistics that is very interesting ones. So we load this library data table, and then we will change our data using data table function. So here we change our data using the data table function and save on the same name. So we'll change from the data frame, we'll change to data table. So here we'll see the head of our data. Then after we'll see how the data subsetting and indexing in R. The data indexing and subsetting in R is now straightforward. Data indexing, straightforward. The one thing we can do is for indexing a single variable, for example, a single treatment. If you want to see what is the treatment 10 or treatment 50 looks like, if you are interested to see. So what you're gonna do is first you write the name of your file, and then you will put the indexing variable like this. For example, our indexing variable in this case is treatment. So we will write which treatment you are interested in. This case, for example, treatment 14, and then we can ask now from the data that using as index treatment, select treatment 14, and then show me all the columns of that variable. So when we see that all the treatment 14 is indicated here, and then we'll see all the data associated with treatment 14 be listed here. So like that we can select, and also if you are interested to select a data only with a specific column, we can also list that one. That can be done like this. For example, can name the data, and the same thing we can use the indexing factor, and then we can list the column what we have been interested to see, for example, like here. So then we'll see only the selected portion of the data frame can be available. In addition, in the subsetting, if we are interested to subset from the large data set, if you are interested to select a portion of the data, can also do like that. For example, if you want that, I want to select the data, and then from the data I will use as indexing location, and then from location select Koji, and then I will give the name BEK, and then after I can use the data as an name Koji for further analysis if I am interested to use it like that. So here, for example, BEK, we have only 45 observation and 10 variable, but the rest will have 135 observations. Good. After we see how to index, import the data, and then now we will go to the summarizing the data and see how our data is comport in our system. So the first one we want to use the simple base function called summary. This function summary will give us, for the factor variables, it will give us the count, but for the quantitative trait, it will give us 5 numbers like minimum, maximum, first quartile, third quartile, median, and mean. This is very informative information that will give us some evidence how our data looks like. So when you go to this hectoliter weight, it also have some error, some problem. As you see, the minimum is 0. That should not be the case. In this data also, the minimum and the maximum is the same. The other is missing a lot of missing plots. Maybe the data have some really very have a problem. So in this manner, we can see what is the problem here in this case. In addition, the other one is from this we can use one interesting function from it can be used by when we change our data. The data table is can summarize easily what the summary statistics, especially the descriptive statistics. I'm interested here, for example, how we summarize is like that. First, we'll give the data name, and then we'll make comma, and then list all the function we have been interested. For example, here the average, it is mean, minimum, maximum, and variance. And all this data analysis should be done based on variance. So it will consider based on treatment. For each treatment, considering each treatment, we will produce all this information that can be helpful. Now I will see all the treatment here, average from each treatment, minimum from each treatment, maximum from each treatment, and variance from each treatment. So this will give us how the general information, if they have constant variance or not. Here, for example, or more or less, the minimum is 50 something, but the maximum is 150 something, 3 times of that. So there is some variation in some treatments. So this will give us the same. So the same thing, we can summarize this one based on the location. For the location here, PLH, here also PLH, can change it. Then here also you can change as a PLH. Then if you run for location, so we'll see it. This is the average of the location, average, maximum, and variance. Good. The other one is we can also do for the interaction. Here is for the interaction. For example, if we put for this the same trait plant height, so it will produce for us for treatment and for each location. So the combined output will be given. So here, if you check for it, you will see how the data is. For example, for each treatment in each location, average, maximum, minimum will be there. For the Bakoji, for Kofali, like that, we'll have an information. Okay, the other part is maybe if you are interested, the mean value for each treatment, for each variables. We can, for example, here DMA, plant height, and also here DMA. So now I am interested to have the yield average, the mean average plant height, the maximum of dice to maturity, variance of grain yield, and instead of grain yield, it will be change it like dice to maturity. Here also the same thing will be days to maturity. Here also will be the same thing, days to maturity, and then PLH. So we'll run by treatment for each treatment. So then we'll see it how it works, like this: average for days to maturity, average for plant height, maximum for days to maturity, variance for days to maturity, and variance for plant height. So in each case we can summarize our data in order to get information. Okay, then the other part is graphical data inspection. This graphical data inspection is very interesting one, so that we can see graphically how our data is look like. So for this graphical inspection, we can use this graphic for graphics, focusing on graphical package. So we will import this library so that we can use after. So one of the best plotting method is using ggplot. So this ggplot, what we're gonna do is first we use ggplot and we'll give the data, and then we'll give the aesthetic value, means the x and y value, so that here in the case here is the x is the treatment and the y is the plant height. Or so we can do it like this: x treatment, y is plant height. So this is the data. Okay, this one is mapping, Excel mapping. So with this I will have only the mapping, but next with using this ggplot is we can, with the layering system, we have one plot, then we can add something over it. So now I have the base plot, then I will add the box plot, a geom box plot that will produce for me as a box plot. Here it is a box plot. So from this box plot, as we see, we have a lot of outliers here, 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 here. But this one is not as such informative because this data include the data from all the locations, so that will not give the real picture of our data. So we should desiccate it into each location. Another one is we can use also this function bwplot from lattice, function from lattice, so that it will produce for us this package, this graph, the same graph but in different things. So here also we have outlier here, some outlier here, some outlier here, but the same thing, this plot is done for each treatment, so it will not express exact data property. Okay, so in order to see, but for each location as a data inspection, we should produce this one for each location. So what gonna do, how we gonna do it? In the case of lattice, we can use like this bwplot xplh, this one, and then trt dot, and then we'll use location data with that. So then here we'll solve the formula will be plant height versus treatment, but in each location. So using this lattice package, we'll get this output. So in this case, as you see, we have the box plot from each location, so that we can see how the problem of our data is. For example, in the case of Holata, we have good variability, but in the case of Bakoji and Kofali, there is a large variation within treatment that is very difficult. So that we should see our data and inspect what is the problem within it. Also, this type of the same analysis can be done using ggplot also. ggplot2, this can be done like this, can do the same thing here, gplot p and then plus geom box plot, and then we'll add facet location. Yeah, so like this we can put our box plot for each plant height. So for each location, we will go to the box plot for each location, as you see here, Holata, Bokofale, Bakwaji, and we'll get all the necessary information from this, so that when you see that, we'll see where is the problem. Sometimes the large variance is observed here at Kofale and here at Bakwaji, especially this treatment 13, treatment 14 here, and also treatment 1. But in Bekwajin, there is not as such, but in the Nkofali, this one is have a big difference among. So we'll see and inspect what is the problem. So if we are interested to see the background to be white, we can use also this one. So with this, we can see how the plotting can be arranged in different facets. Okay. So this will help us to identify which data have some problems. But also, if we are interested, we can also use the ggplot. Also can help us to produce a density plot. The same thing. When we plot the density plot, we'll use a unique plot, so that we'll use here plant height, for example. Then let's go. And then we'll see how our density plot will be plotted like this. This is the whole one. But if you are interested even in faceting it, grid, can facet grid, facet wrapper, warp. You can use this one also. Think, for example, like that location. So for each location, if you're interested for the grid, yes, for the Bakwaji, for the Holata, and also for the Kofale, we'll see how our data is in different locations. So this can be done like this. Okay, we can also use the this density plot command for the using from the lattice package, this one, and also this one can use. So the same thing we can produce from different groups. Okay, then finally we will go to the data point identification with a problem. As last time we see from the box plot, we have found that treatment 40 have some problems. So what is treatment 30? What is the problem? So with that, we can use this command, which command, and see how the treatment 14 is look like. So this will give you this type of data. So when you see treatment 40 in the plant height, in this part it's okay, whole data. But in the case of Bokwaji, there is a lot of variation from 98 to 120. It's about more than 20 centimeter difference. The same thing happened at Kofali. So what is the problem with that replication? Is there something wrong, or something we should, as a researcher, we should answer that problem? In addition, if you are interested to see the certain part of the column only, can use this. We have this treatment, for example here, treatment 14. But from this, we'll only want interested only treatment, granule, rep, and location column. So here we can run it. So this will be granuled NA because you don't have the data for that data point So maybe you can substitute here the plant height, so that we'll see it. So that's it for the plant height. So we can select portion of the column and we are interested respect to that treatment. Then finally, if in this case what you have been seen is, for example, in treatment 14 at Bakoji 98 or at Kofali 92 has that TRT 40. So now I will ask which the data value is 92 and treatment 40. So let's go. Yeah. Now with the data value 92, but and the treatment number 14 is located on 116 row number, so that I will change that one with what I'm interested. So if you are interested to substitute it, it's possible to substitute it. So if I will go for that, our data, and then we index 116, and for the plant height, so we'll see 92. So if you want to substitute it with other like that, for example, NA, can put NA here, then it will substitute the value of the plant height on row number 160 will be substituted by NA. That will be how we can substitute it. Okay, so finally we'll go for identifying outliers. So for the outlier substitution, to get the outlier, what you're gonna do is, one is first, one thing we can follow to identify the outlier is to see the equations. So the equation to identify outlier is, one is we have the first quartile minus 1.5 interquartile range. The other one is the third quartile plus 1.5 times interquartile range. So in order to calculate that range, first we can estimate our data. So in this case, for example, here, sorry, we'll delete it. And then for here, dot PLH, we can calculate the interquartile range. So here the interquartile range is 20.5. And then even we'll see here, for example, dot dollar PLH. Okay, here when you see here, we have minimum, first quartile, median, mean, and then just like that. So then in this case, the outlier will be what? From the dot plant height. Sum 2 means from the sum we have put here, the second one is the first quartile. Sum 2, like that, for example, so for the first quartile, yes, minus 1.5 interquartile range, or, and the other one is dot, then here is PLH, and this one is the fifth one is the third quartile, yeah, plus 1.5 interquartile range. So this will be the average. The interquartile range will be this one. So in this case, if we find some number, no. So there is no any outlier in this context. The other statistical tool can be used with box plot stats. So this is the same thing, and also that we will put the data here, PLH, and then we can see the output. So here also the same thing, we don't have any value that is out of the range of this in this principle. Okay, the other function we can use for this further analysis to find outlier is the library outlier. So this library outlier have different functions that can be used to test if there is the existence of outlier or not. One of the tests is graph test. So this test will be used to identify the outlier from our data set. So this one, and then this one. The lost value is 80. It's considered maybe an outlier, but the p-value here, the p-value, what you have been seeing is 1, means there is no any significant. So means there is no any outlier in this case consideration. But the suggestion here give is, since there is one value very low amount, that's 80, so you consider as an outlier. That's all. Okay, so if we are interested which value is that, so dot page, and then the value here he put is 80. Here is an outlier. He considers the lost value is 80. So if you're interested which value is there, can run it. And the 13 row is 93. So that 93 row is the one can be considered as outlier. But that is a suggestion. But in the case of this, as not outlier. Okay. Okay, then another one is very interesting one that can be used as using to detect an outlier is the function that can be found from library method. This is a good one. So here we can use the data. The data will be dot, and so the variable will be plh, the variable of our interest, plh. And then if we are interested in each environment or in each treatment, we can put here. So for example, for each treatment, we can ask find outlier if there is in each treatment. That is the best way. So that we'll run it. So for each treatment, treatment 1, treatment 2, there are some treatments, for example. So number of possible outliers is for treatment 1 there are 2, treatment 3 2, treatment 7 I consider 1, treatment 9 1, treatment 14 we have 2, probably considered as an outlier. So this is how they can identify for each groups. Okay, so with such things as you see, for example, if you consider this to check for each treatment, as we have seen it, our data is that. Okay, here as you see it, for treatment 1, here we see as an outlier. For example, for treatment 1, as you see for the treatment 1, there is 2 outliers. The same thing here too. And also treatment 3, we have 2 outliers. And also in treatment 7, we have 2 outliers. And also we have in treatment 9, we have 1 outlier. And also in treatment 11, we have another outlier. And also in treatment 14, we have another outlier. Yeah, that's the case. But if we, this is all what I have. So I will see you in my next video. Thank you very much for your attention.